Good morning, students. Continuing with type 2 problems in projection planes. In the previous video, we have discussed about problem number 5, which is on a triangle plane. Similar to that one, we have two more problems with respect to pentagon and hexagon. To just go with the problem, a pentagonal lamina of side 25 mm is having sides both on HP and VP. The corner opposite to the resting side which it reads is 15 millimeter above HP. Draw the top and front view of the lamina. That means uh, he has not given any clue with respect to the third and first position. But if you read this second sentence carefully, we can understand the first and the second positions respectively. That means the corner opposite to the side on which it rests. That means the side on which it rests is resting on the side, okay, which is 15 mm HP. It is similar to the problem number 5 itself. And the third position is one of the side is on both HP and VP. So how exactly we are going to do that, we'll see as we move on with the solution. Okay, so if you compare that one with respect to the problem number 35, where only the change in the lamina. Okay, so here what it says, there is an hexagonal lamina of side 30 mm lying in such a way that one of the side touches both the reference plane. One of the side touches both the reference plane, and the one of the side on HP and VP both remain same. Okay, so reference plane is nothing but HP and VP, and here instead of a reference plane they have given HP and VP. And here if the side opposite to the side on which it rests is 45 millimeter above the HP, and when we look, okay, the position, first position of the pentagon and the hexagon, we'll come to know what these two sentences makes a difference. Okay, so just to understand that both the things, so let's take up, okay, one pentagon problem. Okay, so if you already solved problem number 19, okay, so you can just copy paste the problem. Just we'll see here by deleting the second and third position. Okay, so this is what is the first position says. Okay, pentagon, when pentagon is resting on of its sides is the side lying left side to the observer. Okay, and this is how exactly it is placed. And if I take the same with respect to the hexagon, okay, so 30 0, then 30 60, then 30 120, and 30 180, then 30 240, then 30 300. It comes to this end. Now we need to see whether this is resting on a side or a corner. So this represents resting on a corner condition, so we need to rotate this one. So always take the horizontal one. Okay, so this is how exactly it is rotated. So when it is resting on a side, the opposite side, here we have an opposite. But when we have a pentagon resting on the side, there will be opposite corner. That is what is here we need to understand. Okay, in the 25, he says the corner opposite to the side on which it rests is 15 millimeter above. But here, the side opposite to the side on which it rests. That means in the hexagon, we get a one side opposite to the resting side. But in pentagon, we get a one corner opposite to the resting side. But the rest and all will remain same. Procedure will remain as it is. So let's take up this one only. That's a pentagon. So it is resting on one of its sides. Okay, in the next one, the opposite corner, the corner opposite to the resting side is 15 millimeter above. In the previous one also, that's problem number 5, we have discussed the same. So what normally we do here is we'll take first a 15 millimeter above. Okay, and we'll just draw one horizontal line, and just for a time we'll delete this line. We'll delete this line, and then uh, we need to know the length of this one. We need to know the length of this one. So first we will measure the distance between this end and the dead end of this one. It is 38.47. Now we'll go to a circle by, sorry, arc by center point, arc by center point. Okay, any one point on the XY line, and the radius will be 38.47. Enter, cut it on the XY, this 50 line. Okay, so once this one is done, go to the trim option, trim this extra line, extra arc. Now before that one, we forgot to measure the distance between this and this. Let's measure it. Okay, and now in the previous, that's a problem number 5, we had only one line, but here we have a two lines which are differentiated because we need a reference at this point in the second position. For that one, what we do here, we are not going to draw a single line from end to end. We'll move this line. We'll go to the move command. We'll move this line from the left hand. Where to keep this one? At the initial point of the arc. How to get that one? Move on the arc. You will get this plus mark. Keep it here. Then go to the rotate command. The left end and the right dead end to the end of the arc. Okay. Now measure the angle between the lines, this line and this line. So it is 23. Okay. The rest method will remain similar to the uh, type 1 problem, where we'll move these naming here 1, 2, and 3. Okay, then we'll take a projections. So either we said we can go for a trim corner or alignment indicator. Let's go for a trim corner. That will be simple. Let's take up and move all the lines. Go to the trim corner. A is here, so B is here, C is here, D is here, E is here. So now go to the line, it's a 0.5, and connect A to B, to C, to D, to E, then to A. Okay, now move the names here. Okay, so that's how exactly you do the second position. Okay, that means in the problem number 5 and this one and as well as 35, the method remains same, but only thing is here we have a two discontinuous line. So we'll copy this and move this line here. But in the previous one, we had only two lines. That's a two endpoints. So we just drew one line. Okay, in 35 also you are supposed to take the front view of the line and move it here and then rotate. Now when it comes to the third position, the edge on which it rests is on both the reference plane or on VPHP. So we'll take a move, okay, from point B. We'll keep it on the XY line, and then we'll go to the rotate command. We'll rotate in such a way that this AB will be on the XY line like this. Okay. Now let's go to the move command. So this A will take it here. This B will keep it here. C will keep it here, and D here, and E will keep it here. Now, how to get the projections here? So here is a simple one. We'll go with the one alignment indicator because AB is already on the XY line. So we need to project that one. So E we will project till point E, and C will be on the same point. Then E will be here. Then we'll change that one to 0.5. We'll connect one year, one year, one year, and one year. And anyhow, already we have a line here which is situated. Okay, now let's go to the move command. A is here only, B is here only, and C will be here, D will be here, and E will be here. Now let's go to the text, put a dash. So here change it to Roman, because in the previous one we took it as a symbol. So move, little bit zoom, A dash. This is how exactly aim to get the third position. Okay. So one of the touch edges will be on the both the reference plane. Even in the hexagon, the resting edge should be kept like this, and we are going to drop the projection. Okay. So read the problem carefully. It gives almost clarity on the what exactly to be done and all. Understand the concept. Then doing it in a software is the easiest way. Okay. So thank you.